Welcome to another IB Environmental Systems and Societies video. Today's video is about ESS topic 8.2, Resource Use in Society. This topic examines how humans use natural resources and the implications of that use for sustainability. As you can see from this crowded street scene behind me, our growing population creates increasing demands on Earth's resources. We're going to explore the concepts that are going to help you succeed in your ESS exams, so let's get into it. Renewability depends on how quickly resources can be replaced in nature. Renewable resources can be generated or replaced as fast as we use them. Replenishable resources are replaced more slowly, but they can be replaced. Non-renewable resources are finite and cannot be replaced within human timescales. Remember from topic 1.4 that sustainability means using resources at a rate that allows for natural replacement. Renewable natural capital includes resources that can be replaced quickly. This includes living species and entire ecosystems that harness solar energy through photosynthesis. Examples include forests, fish populations, and agricultural crops. It also includes non-living components like groundwater and the ozone layer. These renewable resources naturally restock themselves through growth and are often, but not always, the biotic components of ecosystems. Non-renewable natural capital can't be replaced within human timescales. These resources formed over geological time periods spanning millions of years. Fossil fuels like coal, oil, and natural gas are prime examples. Once they're burned, they can't be regenerated. Similarly, minerals and soil take extremely long periods to form. When we extract and use these resources, we're depleting a finite supply. Renewable natural capital can be used either sustainably or unsustainably. The key concept here is natural income, the growth or yield produced by natural capital. Examples include agricultural harvests, timber growth, or increases in animal populations. When harvest exceeds growth, we deplete the resource. A sustainable approach ensures that we only use the natural income and we preserve the original capital. Natural income is like interest from a bank account, except instead of increasing your money, you're growing natural resources. If you only spend the interest, your original savings remain intact. With natural resources, if growth exceeds the harvest, then stocks will increase. But if the harvest exceeds the growth, stocks will go down. Sustainable use means using only what regrows, like cutting trees at the same rate that they regenerate or catching fish at the same rate that they reproduce. Even renewable resources can become unsustainable due to how we extract, transport, and process them. Take fishing as an example. Technologies that increase fishing efficiency can lead to overharvesting, and that depletes fish populations faster than they can reproduce. This creates a destructive cycle. As fish become harder and harder to find, fishing technologies become more aggressive, and that further depletes populations until a collapse occurs. For your exams, you need to outline examples of mismanaged resources. Choose one renewable resource, like solar energy in Africa, and one non-renewable resource, like fossil fuels. For each of those, you should identify sustainable management strategies, contrast them with the actual practices, and then describe the consequences. Consider why resources with abundant potential, like solar energy in Africa, might not be optimally utilized. The second significant idea is that the status and value of natural capital is dynamic. It changes over time. Resources don't always have purely economic value. They may have cultural, religious, or intrinsic value. Remember the environmental value systems from topic 1.1? People with different EVSs will value resources differently, from ecocentric to technocentric perspectives. Natural capital provides both goods and services. Ecological goods are tangible products like metals from ores, electricity from water, crops from soil, and timber from forests. These are physical resources that we extract and use. However, many of the most important benefits from nature aren't physical products at all. Values of natural capital can be categorized as use values or non-use values. Use values require human interaction with the resource, like direct use of timber or indirect use through ecosystem services. Non-use values exist whether humans interact with the resource or not. It's like an existence value, right? That's valuing that something simply exists, or a bequest value, which is preserving resources for future generations. Ecological services are benefits that are provided by ecosystems which aren't typically monetized in traditional markets. These include oxygen production, carbon sequestration, water purification, flood control, and climate regulation. Without these services, human societies can't function, but we rarely pay directly for these services. This makes them vulnerable to degradation because their value isn't actually reflected in market prices. Mountains provide a bunch of different ecological services. They store water as snow and ice, they regulate climate, they protect watersheds, they provide habitats for unique species, and they offer spiritual value to many cultures. Some goods from mountains include minerals, water for hydropower, medicinal plants, and agricultural products. Understanding these interconnected benefits is what helps us recognize the full value of ecosystems. The value of natural capital varies dramatically over time. This graph shows uranium price fluctuations over many decades. These changes reflect shifting technological, political, and environmental factors. For example, prices peaked in the 1970s during nuclear power expansion, and then they fell after accidents like 3 Mile Island and Chernobyl all raised safety concerns. More recently, climate change concerns have renewed interest in nuclear energy, and so its price is climbing again. The dynamic nature of natural capital is perfectly illustrated by coltan, a mineral once considered nearly worthless. It contains tantalum, essential for manufacturing electronic capacitors in smartphones, computers, and gaming consoles. As technology has evolved, the demand for coltan skyrocketed. Now it's mined in conflict zones like the DRC, where its extraction funds armed groups and causes environmental devastation. Different cultures value natural resources differently. Consider wildlife reserves in East Africa. Tourists value them for viewing wildlife, while many local communities might value them for grazing livestock or hunting. Similarly, wilderness areas might contain plants with medicinal properties, and that creates ethical dilemmas. Should we protect pristine wilderness or explore it for potentially life saving compounds? These kinds of questions highlight how resource management involves complex value judgments. That's it for topic 8.2, resource use in society. If you remember these tips when you're studying, you're going to do well in your ESS exams. Good luck, and until next time, happy learning.